We've been waiting a long time for the future we were promised. Ever since a glowing blue princess flickered to life in empty space, or billionaire superheroes swiped their hands through floating blueprints, we've expected a world filled with three-dimensional light. Yet, here we are. We walk around with supercomputers in our pockets that possess millions of times the processing power needed to land Apollo on the moon. Despite all that raw processing speed, our digital lives remain stubbornly trapped behind flat, two-dimensional rectangles of glass. That classic sci-fi vision of a floating, glowing avatar is delayed because it relies on strict biological and physical impossibilities rather than actual science. This diagram outlines basic optics. In reality, a photon of light travels in a continuous straight line. It keeps moving forward until it strikes a physical surface, which then scatters that light into your eye so you can process the image. Watch what happens when we try to create a hologram in empty air. If a projector shoots light into a void, those photons will not hit the brakes in midair and bounce back to your retinas. They keep traveling endlessly into the darkness. Making a free-floating image appear in the center of a room with absolutely nothing for the light to bounce off of requires breaking established laws of optical physics. Since we cannot rewrite the laws of the universe, whenever you see what appears to be a hologram in the real world, you are looking at a carefully engineered optical illusion. You might recall a massive cultural moment in 2012 when millions watched footage of a resurrected Tupac Shakur pacing the stage. This trick was deployed live in front of tens of thousands of screaming fans at an outdoor music festival, successfully fooling an entire massive crowd at once. That performance relied entirely on a scaled-up parlor trick from the 1860s, known as Cupper's ghost. This diagram demonstrates the mechanics. A highly bright, two-dimensional video is projected from below, bouncing off a hidden piece of angled glass or transparent mylar foil. The audience sees the reflection, creating the perception of a ghost-like figure standing on the stage. To get actual three-dimensional computing, interfaces we can interact with and walk around, we have to ditch these Victorian theater tricks and engineer physical depth. The first real attempt to bypass the empty air problem brings us to volumetric displays. Instead of fighting the need for a physical surface, this technology provides one. It uses rapid-fire lasers to trap and illuminate tiny, individual physical particles floating in midair, literally drawing shapes in space. A second approach, known as light field technology, solves the 3D problem mathematically rather than by physically moving matter. Looking at this schematic, we see a specialized flat screen emitting millions of distinct light rays at incredibly precise intersecting angles. It calculates the geometry of an object and fires the correct light rays directly into your retinas to simulate depth. Both volumetric and light field systems succeed in producing genuine depth, but they are severely constrained by the bulky hardware required to project them. The most viable path forward discards the idea of a room-scale projector entirely. We call this approach spatial computing or augmented reality. Spatial computing bypasses the empty room by placing transparent, wearable lenses over your eyes, rendering the digital object directly into your retinas. The headset constantly scans and maps the physical geometry of your environment. If a digital object drops, it anchors realistically to your physical coffee table because the system understands exactly where that table sits. The physical space around you remains completely empty. The truest version of a hologram exists strictly as a localized digital construct built inside your visual cortex. This combination of precision environmental mapping and wearable optics is quietly replacing the sci-fi fantasies we grew up with. We spent decades waiting for a magical projector to sit on our desks. What we are building instead is an invisible digital layer seamlessly draped over the real world. This trajectory points toward the eventual obsolescence of the flat display. The 2D rectangles we use for work and communication will dissolve into the physical space around us. We will transition from simply looking at a digital world through a glass window to living inside of it, interacting with information as naturally as we interact with furniture. The holographic tomorrow has not failed to arrive. It simply outgrew the boundaries of science fiction, shifting from a neat optical trick in the center of a room into a total redefinition of human sight.